All right, today we're going on an absolutely incredible journey, climbing up through the invisible layers of air that wrap around our planet. This is the story of the shield that makes all life on Earth even possible. So let's start from the ground up.
So, have you ever really stopped to think about it? What exactly is standing between us and the infinite, frozen emptiness of space?
Well, the answer is this, a surprisingly thin blanket of gas that we call the atmosphere. It's held here only by Earth's gravity, and yeah, it feels huge to us. But from space, it's no thicker than the skin on an apple. Just a delicate, crucial veil protecting everything we've ever known.
So this gaseous shield, it's pretty much our first and last line of defense. Not only does it have the oxygen we need to breathe, but it also protects us from the sun's most dangerous radiation. It's actually split into these distinct layers, and each one has its own unique and totally vital job to do.
So let's begin our climb. We're going to travel upward through 4 major steps, from the troposphere, right here where we live, all the way up to the very edge of space.
Okay, our first stop is home, the troposphere. This is the layer you and I experience every single day. It's the air we breathe, the wind we feel. It's the stage for basically all of our weather.
The troposphere goes up about 10 kilometers, or 6.2 miles, but it really packs a punch. I mean, it's got 99% of all the atmosphere's water vapor. And what does that mean? It means that pretty much all our weather, clouds, rain, storms, you name it, it all happens right here. And as anyone who's ever hiked up a mountain can tell you, the higher you go in this layer, the colder it gets. Now, climbing above all that weather, we enter the stratosphere. And up here, things are completely different. It's calm, it's stable, and it's home to one of the most critical protective features on our entire planet.
And that feature is, of course, the famous ozone layer. The best way to think of it is as Earth's planetary sunscreen. These little ozone molecules in this layer just soak up the sun's most dangerous UV radiation, turning it into heat and stopping it from ever getting down to us on the surface.
So, this is where things get a little weird and kind of counterintuitive. Unlike the troposphere we just left, the stratosphere actually gets warmer the higher you go. So why is that? Well, it's because that ozone layer is absorbing all that UV energy from the sun, which basically heats this layer from the top down. It creates this really remarkable temperature inversion. Now, this temperature inversion creates incredibly stable air. There's none of that turbulent weather we have way down below. And that right there is exactly why commercial jets love to fly here, to get above the clouds and give us all a much, much smoother ride.
Okay, let's keep going up. We've arrived at the mesosphere. Now, if the stratosphere is our sunscreen, you can think of this layer as our cosmic shield. It's a true meteor graveyard.
You know, millions of pieces of space rock and debris are hurtling towards Earth every single day. But as they slam to the molecules in the mesosphere, the friction gets so intense that they just vaporize in a brilliant flash of light. So every shooting star you've ever made a wish on, that's really just a little thank you to the mesosphere for doing its job.
But this protective layer has a pretty bizarre secret. After the relative warmth of the stratosphere below it, the temperature up here just plummets. I mean, it reaches the absolute coldest point in our entire atmosphere. That's right. Near the top of this layer, temperatures can drop to a staggering minus 90 degrees Celsius. That's minus 130 degrees Fahrenheit. It is an unbelievably frigid place.
And now we reach the vast final frontier of our atmosphere, the thermosphere, and, way beyond that, the exosphere. This is where Earth's atmosphere really starts to thin out and just merge with the vacuum of space.
We've hit a strange paradox up here. The air molecules are incredibly far apart from each other, way, way too thin to breathe. But the few molecules that are here are absorbing so much high-energy radiation from the sun that their temperature just skyrockets.
How high, you ask? Well, temperatures here can hit an unbelievable 2,000 degrees Celsius. But here's the wild part. You wouldn't even feel it. Temperature is just a measure of how fast molecules are moving. And up here, they're so far apart they would almost never even touch you to transfer that crazy amount of energy. So what's the real distinction here? Well, you can think of it as function versus finality. The thermosphere is still doing a job, right? It's absorbing X-rays, it's bouncing radio waves around. But above it, the exosphere. That's the true end of the line. It's the final bleeding edge where our atmosphere just leaks away into space.
And here's another really cool real-world connection. That part of the thermosphere called the ionosphere, which is all charged up by the sun's energy,
acts like a giant mirror for certain radio waves. It bounces them back down to Earth, and that's what lets us send and listen to shortwave radio broadcasts all the way across continents.
Let's just pause on this idea for a second. In the exosphere, the very definition of air just kind of breaks down. It's not a gas anymore, not in the way we think about it. The individual atoms and molecules are basically on their own, flying on these long paths, and a lot of them just get lost to space forever.
And that just leaves us with this final, kind of humbling thought. Our atmosphere isn't some permanent solid shell. It's this dynamic, living system. And at its very outermost edge, it's slowly bleeding away into the cosmos, particle by particle. It really makes you appreciate the delicate, incredible balance that keeps our world alive.